the water on Mars vanished. Mars was once wet, with an ocean's worth of water on its surface. Today, most of Mars is as dry as a desert except for ice deposits in its polar regions. Where did the rest of the water go? Some of it disappeared into space. Water molecules, pummeled by particles of the solar wind, broke apart into hydrogen and oxygen atoms, and those, especially the lighter hydrogen atoms, sped out of the atmosphere, lost to outer space. But most of the water, a new study concludes, went down, sucked into the red planet's rocks. And there it remains, trapped within minerals and salts. Indeed, as much as 99% of the water that once flowed on Mars could still be there. Data from the past 2 decades of robotic missions to Mars, including NASA's Curiosity rover and the Mars Reconnaissance Orbiter, showed a wide distribution of what geologists call hydrated minerals. If Mars were smoothed out into a uniform, featureless ball, how deep would the water have been? The scientists estimated that the depth would have been 100 to 1,500 meters, or 330 to 5,000 feet. The most likely depth was about 2,000 feet, or roughly 1/4 as much water as is in the Atlantic Ocean. The data and simulations also indicated that the water was almost all gone by 3 billion years ago, around the time on Earth when life consisted of single-cell microbes in the oceans. This means that Mars has been dry for quite a long time. Planetary scientists have long marveled at ancient evidence of flowing water carved in the Martian surface, gigantic canyons, tendrils of winding river channels, and deltas where the rivers disgorge sediments into lakes. NASA's latest robotic Mars explorer, Perseverance, which landed last month in the Jezero crater, will be headed to a river delta at its edge in hopes of finding signs of past life. Without a time machine, there is no way to observe directly how much water was on a younger Mars more than 3 billion years ago. But the hydrogen atoms floating today in the atmosphere of Mars preserve a ghostly hint of the ancient ocean. On Earth, about 1 in 5,000 hydrogen atoms is a version known as deuterium that is twice as heavy because its nucleus contains both a neutron and a proton. But on Mars, the concentration of deuterium is markedly higher, about 1 in 700. Scientists at the NASA Goddard Space Flight Center who reported this finding in 2015 said this could be used to calculate the amount of water Mars once had. Mars probably started with a similar ratio of deuterium to hydrogen as Earth, but the fraction of deuterium increased over time as the water evaporated and hydrogen was lost to space because the heavier deuterium is less likely to escape the atmosphere. The water, however, probably would not be of much use to settlers from Earth. The amount of water that's in the rock is very small. Release the water trapped in minerals requires heating them to high temperatures. Elon Musk, the founder of SpaceX who dreams of sending colonists to Mars one day, has mused about detonating nuclear bombs on Mars to melt the ice caps and warm the planet, making it more hospitable. Those explosions would also release some of the water in the hydrated minerals. On Earth, water is also absorbed in rocks, but it does not stay there indefinitely. The movement of Earth's crust pushes rocks down into the mantle, where they melt, and then the molten rock and water come back up through volcanoes. On Mars, volcanism, like liquid water, appears to have gone away long ago. Wearing a face mask may limit exposure to respiratory droplets and large particles and may help prevent people who have COVID-19 from spreading the virus.